Welcome back to our deep dive into the fascinating history of the Lucasian Professors of Mathematics at Cambridge. This is our 6th episode, and today we're going to shift our focus to John Coulson, the 5th individual to hold this prestigious chair. Now, you might not find his name etched alongside giants like Newton or Barrow, but his story offers a unique perspective on the evolution of mathematics in the 18th century.
What's intriguing about Coulson is that his contributions extend beyond groundbreaking discoveries. He played a crucial role in making complex mathematical ideas accessible to a wider audience, which is a significant achievement in itself.
Absolutely. It's like he recognized that knowledge is most powerful when it's shared and understood. So let's rewind a bit and trace Coulson's path to the Lucasian chair. He takes on the role in 1739, just 12 years after Newton's death. Stepping into those shoes must have been quite daunting, considering Newton's immense legacy.
Indeed. It's worth noting that Coulson's journey to Cambridge was anything but conventional. He began his career as a schoolmaster, far from the hallowed halls of academia.
That's right. He started at Sir Joseph Williamson's Mathematical School in Rochester. It's fascinating to see how his path unfolded, eventually leading him to become a Fellow of the Royal Society in 1713.
His trajectory then took him to Cambridge, where he lectured at Sydney Sussex College. Interestingly, he didn't receive his MA until 1728 at the age of 48, which speaks to his commitment to lifelong learning.
It challenges the notion that academic success follows a linear path. He eventually secured the Lucasian chair in 1739, a position he held until his death in 1760. Now, while the Lucasian chair is deeply rooted in mathematical tradition, Coulson wasn't just a numbers guy. His interests spanned languages, philosophy, and even religion.
Precisely. This multifaceted background likely influenced his approach to mathematics. One example is his development of Negativo-Affirmativo arithmetic. While the name might sound a bit like a secret code, it represents Coulson's efforts to simplify complex calculations.
So how exactly did this system work? What was its significance in the context of 18th century mathematics?
Imagine a time when all calculations were done by hand. Coulson's system utilized negative numbers, a relatively new concept then, to streamline these operations, particularly when dealing with large numbers.
It's like he was developing a more efficient set of tools for mathematical work. Did his system gain widespread acceptance among mathematicians of the era?
While it didn't revolutionize mathematical practice, it highlighted Coulson's focus on the practical application of mathematical principles. He was always seeking ways to make math work better in the real world.
This emphasis on practicality seems to be a recurring theme in Coulson's work. And speaking of practical applications, didn't he also invent something called a counting table to aid in calculations?
He hinted at such a device in his writings, but unfortunately no detailed descriptions or schematics have survived. Its exact nature remains a mystery, lost to the mists of time.
It's almost like a hidden chapter in Coulson's story waiting to be rediscovered. Perhaps one day we'll uncover the secrets of his counting table.
Now, shifting gears a bit, it's essential to recognize Coulson's significant role as a translator. He played a pivotal role in bringing the works of Newton and other influential thinkers to a wider English-speaking audience.
His translation of Newton's De Methodis Seriorum et Fluxionum in 1736 stands out as a prime example. Making these groundbreaking ideas accessible to a broader readership must have had a considerable impact on the dissemination of knowledge.
Absolutely. He wasn't simply translating words. He was conveying complex mathematical concepts in a way that made them comprehensible to a larger audience, which is a skill in itself.
It's like he was building a bridge between the often intimidating world of advanced mathematics and those who were eager to learn but lacked the specialized language to access it.
That's a great analogy, and this brings us to another fascinating aspect of Coulson's legacy, his remarkable foresight in championing women in STEM, centuries ahead of his time.
Now, this is something I find particularly interesting. Could you elaborate on his efforts in this regard?
Well, in an era when women were largely excluded from higher education, Coulson recognized the importance of making advanced mathematics accessible to them.
It was a time when societal norms often limited women's access to educational opportunities, particularly in the sciences. So how did Coulson challenge these norms?
He undertook the translation of Maria Agnesi's Analytical Institutions, a groundbreaking work that holds the distinction of being the first calculus textbook written by a woman.
So he was intentionally trying to bring this knowledge to a female audience. That's quite progressive for the 18th century.
Precisely. His translation underscores his commitment to inclusivity in education and his recognition of the untapped potential of women in the field of mathematics. Sadly, his manuscript didn't see the light of day until 1801, long after his death.
That's unfortunate. Imagine the impact it could have had if published during his lifetime. It might have inspired generations of women to pursue mathematics. It makes you wonder how many other groundbreaking contributions have been lost or delayed due to similar societal barriers.
It certainly highlights the importance of recognizing and supporting diverse voices in STEM fields throughout history. And speaking of Coulson's commitment to inclusivity, he also worked on another manuscript titled The Plan of the Lady System of Analytics, which further demonstrates his dedication to making mathematics accessible to women.
It seems he was quite determined to break down those gender barriers in academia. Where is that manuscript now?
It's currently held in the Cambridge Library, serving as a testament to his forward-thinking approach to education.
It's remarkable how Coulson's legacy extends beyond his own mathematical work. He was a true advocate for knowledge and its accessibility. Now, we talked a lot about his role as a translator and educator, but what about his own contributions to mathematics? Didn't he publish several papers on various topics?
Yes, indeed. Aside from his work on Negativo-Affirmativo arithmetic, Coulson published papers on a range of mathematical subjects, demonstrating his diverse interests within the field.
What were some of the specific areas he explored in his research?
One notable paper, published in Latin, focused on a method for solving quadratic and biquadratic equations. This choice of language highlights the continued influence of Latin as the universal language of scholarship, particularly in mathematics and the sciences, even as English gained prominence.
It's fascinating to see how these linguistic transitions played out in the academic world. So in addition to his work on simplifying calculations, Coulson was also delving into more abstract mathematical concepts.
Precisely. Another paper, this time published in English, delved deeper into his negativo-affirmative arithmetic, providing a more detailed explanation of its principles and applications.
It seems this concept was a particular focus for him. Can you remind us again how this system worked and what advantages it offered?
Certainly. At its core, negativo-affirmative arithmetic involved using a combination of negative and positive digits to represent numbers, almost like a coded system. Coulson devised specific rules for converting standard numbers into this form and back again, as well as rules for performing arithmetic operations using this system.
So it was more than just a different way of writing numbers. It was a complete system for calculation. Did he claim any practical benefits for using this method?
According to Coulson, his system could significantly speed up the multiplication of large numbers, a tedious task when done by hand. It's a testament to his ingenuity and his desire to push the boundaries of practical mathematics.
It's a reminder that innovation often lies in finding clever solutions to everyday problems. And this drive for practicality wasn't limited to his work with numbers. Didn't he also apply his mathematical skills to the field of mapmaking?
You're absolutely right. His final paper, also published in English, tackled the challenges of mapmaking, specifically the complexities of converting between a flat surface and a spherical surface, a problem that has fascinated cartographers for centuries.
Yes, the age-old challenge of representing our three-dimensional world on a two-dimensional plane. It's a problem with both practical and theoretical implications.
Indeed. And Coulson's work in this area demonstrates his understanding of geometry and its real-world applications. He seemed to constantly seek ways to connect mathematical principles with tangible solutions to real-world issues.
It speaks to his belief in the power of mathematics to shape and improve the world around us. It's a perspective that resonates even today, as we see mathematics playing an increasingly vital role in fields ranging from technology to finance to medicine.
Absolutely. Now, beyond his published papers, we've already touched on his incredible work as a translator, particularly his efforts to make complex scientific knowledge more accessible. But there's another layer to his translation work that we haven't explored yet: his connection to the world of navigation.
His involvement in navigation seems like an unexpected twist for a Lucasian professor. How did he become engaged with this maritime world?
It stemmed surprisingly from his passion for translation, alongside translating complex mathematical treatises. He was deeply involved in translating and elucidating works related to navigation. You could say he was a one-man knowledge dissemination machine.
It's fascinating to see how his interests intertwined. So what were some of the specific navigational works he tackled?
He made significant contributions to publications like The Mariner's Magazine and The Mariner's New Calendar. These were publications aimed directly at a seafaring audience and contained practical information on a wide array of nautical topics.
So we're not talking about theoretical mathematics here, but rather the hands-on knowledge needed to navigate the open seas.
Precisely. Coulson translated and provided commentary on material covering geometry, trigonometry, the principles of sailing, and even the art of navigating by the stars, both day and night. His work provided a comprehensive guide to the skills required for successful seafaring.
That's an impressive range. It sounds like he was essentially creating a bridge between the theoretical world of mathematics and the very practical demands of life at sea.
And remember, this was a time when accurate navigation was paramount, not just for exploration, but also for trade and naval warfare. Coulson's work could have had a real impact on the lives of sailors and the success of maritime ventures.
It's incredible to think that a mathematician primarily known for his work in academia could have played such a tangible role in shaping the maritime world.
It highlights the often unexpected ways that knowledge can transcend disciplinary boundaries and have real-world impact.
It's a reminder that innovation often occurs at the intersection of seemingly disparate fields.
Exactly. And Coulson's contributions to navigation weren't limited to translations. He went beyond that, delving into explaining complex concepts related to sailing and seamanship.
Can you give us a specific example of how he approached these nautical challenges?
He provided insightful commentary on Mercator's principles, a groundbreaking method for nautical chart projection that revolutionized navigation. By allowing sailors to plot courses across vast oceans with greater accuracy.
Ah, yes, Mercator's projection, those distinctive maps we've all seen with their stretched-out land masses near the poles. It's a projection that sacrifices true area representation for the benefit of navigational ease.
Precisely, Coulson's explanations of this projection would have been invaluable to sailors, enabling them to grasp its underlying principles and use it effectively for plotting their voyages.
It's another fantastic example of his ability to connect theoretical concepts with practical applications, bridging the gap between the world of scholarship and the world of action.
It truly showcases his remarkable skill as a communicator and his unwavering dedication to making complex knowledge accessible to those who needed it most.
So we have a mathematician who is not only comfortable in the world of abstract equations, but also eager to roll up his sleeves and delve into the practicalities of navigation, a field that back then relied heavily on experience and intuition.
His story paints a picture of a man deeply engaged with the world around him, always seeking ways to apply his knowledge to solve real-world problems and ultimately improve people's lives.
It's a powerful reminder that the pursuit of knowledge shouldn't be confined to the ivory towers of academia. It should have a tangible and positive impact on the world we live in.
Couldn't agree more. And Coulson's life exemplifies this principle perfectly. His work as a translator, educator, and innovator highlights the enduring importance of making knowledge accessible and applying intellectual pursuits to real-world challenges.
It's a legacy that continues to resonate today, inspiring us to break down barriers between theory and practice, to translate complex ideas into actionable solutions, and to strive for a more holistic understanding of the world.
Indeed. It also reminds us that even individuals who may not be as widely recognized as some of their contemporaries can make profound contributions to the advancement of human understanding and leave a lasting impact on the course of history.
Now, before we move on to the final part of our deep dive, I'd like to touch on one more aspect of Coulson's translation work. He also translated a work on experimental philosophy. Can you tell us a bit more about this translation and how it fits into his broader intellectual interests?
That's an excellent question. While the specific details of this translated work are not readily available, it's crucial to understand that the term experimental philosophy in the 18th century often referred to what we now call natural philosophy.
So it encompassed a broader range of scientific inquiries, including physics, astronomy, and even aspects of chemistry.
Precisely, Coulson's translation of a work in this area suggests a keen interest in understanding and disseminating knowledge about the natural world, which aligns perfectly with his passion for navigation, a field deeply rooted in astronomical observation and an understanding of physical principles.
It's fascinating to see how these different threads of intellectual pursuits come together, forming a rich tapestry of knowledge that span multiple disciplines.
It further reinforces the notion that Coulson wasn't simply a specialist in one narrow field, but rather a polymath, someone who embraced the interconnectedness of knowledge and constantly sought to contribute to a more comprehensive understanding of the world.
And this breadth of knowledge likely played a key role in shaping his approach to teaching and his dedication to making complex ideas accessible to a wider audience.
Absolutely. It's this commitment to education and knowledge sharing that truly sets Coulson apart as a remarkable figure in the history of mathematics.
We've explored Coulson's fascinating contributions to mathematics, his passion for translation, his unexpected connections to the world of navigation, and his broader interest in natural philosophy. It's a truly multifaceted portrait of a scholar who is deeply engaged with the world around him. But there's one more intriguing aspect of his story that we haven't touched on yet: his translation of a work on linear perspective. This is where Coulson's story takes another intriguing turn. We've seen how his mathematical mind thrived on practical applications. But venturing into the realm of visual art reveals another dimension of his intellectual curiosity.
What's fascinating is that Coulson's translation of a work on linear perspective highlights the long-standing connection between mathematics and art, a connection that stretches back centuries.
It's remarkable how the same principles governing numbers can be applied to create illusions of depth and space on a flat surface. It's a testament to the power of mathematics to transcend disciplinary boundaries.
Indeed, linear perspective. A technique that emerged during the Renaissance relies heavily on mathematical concepts like geometry and proportion to create realistic representations of three-dimensional objects on a two-dimensional canvas.
So by translating this work, Coulson wasn't merely engaging with art. He was demonstrating the inherent link between mathematical principles and artistic expression. It's as if he was revealing the hidden mathematical framework behind the visual world.
Precisely. His translation underscores his belief in the universality of mathematics, its ability to inform even fields that might seem at first glance quite distant from equations and formulas.
It's a reminder that mathematics is not just about abstract calculations. It's a fundamental way of understanding and representing the world around us, including the world of visual perception.
That's an excellent point. It speaks to Coulson's ability to see connections that others might have missed, to appreciate the underlying unity of seemingly disparate fields of knowledge.
Do we have any insights into the specific content of the work on linear perspective that he translated?
Unfortunately, the specific details of both the original work and Coulson's translation are not readily available. However, we can infer that it likely covered the fundamental principles of perspective drawing, perhaps even delving into practical techniques for artists.
It's intriguing to picture Coulson, the Lucasian professor of mathematics, immersed in the world of perspective drawing, exploring diagrams and geometric constructions related to artistic techniques. It challenges our preconceived notions of what might capture a mathematician's interest.
It certainly does. And it underscores the idea that intellectual curiosity knows no boundaries. Coulson's willingness to engage with art, a field seemingly distant from his primary expertise, speaks volumes about his open-mindedness and his desire to explore the interconnectedness of human knowledge.
It reinforces the idea that creativity often flourishes at the intersections of disciplines, where different modes of thinking converge and generate fresh insights. It's a reminder that cross-disciplinary exploration can lead to unexpected and enriching discoveries.
And it's a lesson that holds particular relevance in today's increasingly specialized world. We need individuals like Coulson who can bridge the divides between disciplines, who can see the bigger picture, and who can bring seemingly unrelated areas of knowledge into dialogue with one another.
His life serves as a powerful testament to the value of a well-rounded education, one that encompasses both the sciences and the humanities, encouraging us to view the world through multiple lenses. It's an approach that fosters a more holistic understanding of the world and our place within it.
Indeed, Coulson's legacy continues to inspire us to embrace a broader view of knowledge, to seek connections between seemingly disparate fields, and to utilize our intellect to make a positive impact on the world.
So as we conclude our deep dive into the life and work of John Coulson, the fifth Lucasian professor of mathematics, we're left with a portrait of a man who transcended the confines of a singular discipline.
He was a brilliant mathematician, a gifted translator, a dedicated educator, an innovator who sought practical applications for his knowledge, and a true polymath who embraced the interconnectedness of human understanding.
His story reminds us that intellectual curiosity should know no bounds, that knowledge flourishes when it is shared and applied, and that even those who may not achieve widespread fame can leave a lasting and profound impact on the world.
Indeed, Coulson's life challenges us to embrace a more holistic view of knowledge, to seek connections between seemingly disparate fields, and to use our intellect to make a positive difference in the world.
And perhaps it reminds us that even amidst complex equations and scientific inquiries, there's always space for a touch of art and a new perspective.
Beautifully put. That's a fitting tribute to the extraordinary life of John Coulson.
Well, thank you for joining us on this deep dive into the life of John Coulson. We hope you found this journey into the past illuminating, and that you'll continue to explore the captivating world of the Lucasian Professors of Mathematics.